Hello everyone, I'm Jeremy Hedges with American VULKAN Corporation, and today we'll be reviewing safe handling of flammable refrigerants. In this case, R600A, which is the refrigerant contained inside of our Sub-Zero under-the-counter refrigerator that we'll be working on today. We'll be utilizing our American VULKAN charging kit to both extract and to charge the hydrocarbon refrigerants back into the system. As you all know, hydrocarbons have become very popular refrigerant of choice from manufacturers to meet environmental impact requirements. The R600 we'll be dealing with today has an ASHRAE 34 classification of A3, meaning it's A for non-toxic and 3 for highly flammable. And keep in mind that all hydrocarbon refrigerants are going to be classified as A3 refrigerants. Some other common refrigerants that you'll deal with that are flammable will be R32, R452B, R600 as we'll review today, and also R290. Most of these refrigerants are going to be seen in the commercial aspects, and R600 is what we'll see in residential refrigeration. And that's pretty much what our American VULKAN charging kit has been designed to handle. It's going to be anything with R600 for residential appliance. As I mentioned during my introduction, today's focus is going to be on the safe handling of flammable refrigerants. In this case, the refrigerant is inert when it's inside the system because it has no oxygen in it. We need three things to sustain a flame. We're going to need fuel, which in this case the R600A. We'll need air, oxygen, and we'll need an ignition source or a flame. Sudden release of the refrigerant from a cabinet or from an appliance could result in flash fire, a sustained fire, or even an explosion. The most risk is contained in an internal leak inside of the cabinet, where the gas could actually pool, be introduced into the air that's already contained in the unit, and if an ignition source was present, that could be the potential of an explosion. Keep in mind that it's a very small mixture, a small ratio that we have to hit in order to create this flammable environment. It's referred to as our lower explosive limit or lower flammable limit. In the respect to R600, it's a 1.8% concentration limit, meaning we need 1.8% of the R600 to combine with the remaining oxygen in order to promulgate a flame. If we get to our upper explosive limit or upper flammable limit, which would be at an 8.5% concentration level, we actually have too much fuel to promulgate a flame. So just like I mentioned inside of our system being pure R600A, theoretically it can't ignite until we introduce air. A technician can do that by cutting into the system and allowing air to be introduced. So just like with our traditional refrigerators and appliances with our standard refrigerants such as 134A, all the regulations associated with hydrocarbons will be controlled through the EPA and SNAP regulations. One of the big changes that you'll see is no retrofitting. In a case of a retrofit, you may be taking a 134A refrigerator and trying to convert it to an R600. Keep in mind this is currently illegal. And the reason for it is that the R134A refrigerator won't have the intrinsically safe devices like timers and switches that are commonly used with flammable refrigerants. So you could inadvertently convert a refrigerator and it's chocked full of flammable or ignition sources that could present danger to both you as a technician or the homeowner themselves. There are some changes, however. You're going to see a lot more warning labels all over the appliance, including some R600 labels by the compressor. You'll have labels by the evaporator and also on the outside of the cabinet. These labels are meant to allow the homeowner and the technician both know that there's risks associated with this refrigerant. As a technician, there are two really good resources that you can use for additional hydrocarbon safety tips and guides. The first is AHAM, the Association of Home Appliance Manufacturers, and RSES, Refrigerated Service Engineering Society. AHAM has written an instruction for appliance technicians on recommended methodology on how to handle R600 and other hydrocarbon refrigerants, and would highly recommend that you take a read. RSES's textbook on hydrocarbon safety is filled with tips and tricks on handling hydrocarbon refrigerants safely, as well as all of the charge limits for all of the equipment available and dictated through the EPA. At this point in the presentation, we'll be going through our pre-safety check that is in alignment with our AHAM guidelines. The first thing we'll want to do is ensure what type of refrigerant we have in the appliance. In this case, it is R600A, which can be verified on the manufacturer's label plate. We'd also want to have on hand the MSDS associated with that refrigerant in case we need to render any first aid. The next very important piece that's going to help the technician monitor the environment is going to be a combustible leak detector. This leak detector will be used initially just to search for leaks on both the inside and outside of the cabinet. And then we'll continue to leave this leak detector on to monitor the environment as we service the equipment. Next important piece is going to be a fire extinguisher. Just in case we have an incident, we want to be prepared and have firefighting equipment on scene. Another component that we're going to be utilizing is a tube cutter for the removal of all of our tubes. We'll no longer want to use a torch, since this could be the ignition source that would promulgate a flame. The other portion we want to consider is maintaining a well-ventilated area. We're going to do this today by introducing a floor fan that's going to help bring fresh air into the environment and prevent us from ever reaching the concentration of our lower explosive limit. This should help mitigate any flame should we have a leak in our system while we're working on it. And finally, we're going to want to eliminate all of our ignition sources. Some of the obvious ignition sources that we have could be a homeowner who smokes, matches, maybe they have candles throughout the home. The torch itself, the spark lighter you're using to actually ignite the torch, all of these would be very obvious ignition sources. But the first tool we grab as a technician is often a cordless drill. If we hadn't done that pre-safety check with our hydrocarbon leak detector, we may not have noticed that there was actually a pool of gas inside that cabinet. And as soon as you hit the trigger on that cordless drill that's a brushed motor, that could be an ignition source. So that's where we're talking about. Some ignition sources are not as readily apparent as others. So keep in mind, do you have an intrinsically safe tool that you're using? The vacuum pump itself, is it rated to actually work around flammable refrigerants such as A2L, A2, and A3 refrigerants? Now we're moving into leak detection and line repair. And through following AHAM guidelines, we're going to start with only using a tubing cutter to remove any of our tubes. Like I mentioned previously, the torch is going to be considered an ignition source, so we need to move away from that and simply cut all of our tubes. We want to use a certified leak detector, preferably an electronic leak detector when trying to identify these leaks in the system. Keep in mind that R600 on the low side runs in a vacuum while it's running. So if you use soapy bubbles or some type of external fluid to detect leaks, this could be drawn into the system if the system has a significant leak on the suction side. So please keep that in mind, that before running a system, you would want to clean any of those soap bubbles away from the suction side of the system. You can also use dry nitrogen to pressurize the system and to create almost a trace gas using the R600 that's in the system. One of the big benefits of working with hydrocarbon refrigerants is now to find a leak, we can just add nitrogen immediately to the system to raise our pressure to around 100-110 psi to facilitate the use of an electronic leak detector. This should allow us to, in a more timely manner, identify the leak. In the past, we had to recover the refrigerant if there was any remaining, and then add a small trace amount of the refrigerant along with dry nitrogen. We can now eliminate this step because R600 can be immediately released to the environment after we're done with our leak check. One of the major aspects that we want to continue to monitor while doing our sealed system service is going to be constantly monitoring for a flammable environment. We're going to do this by using our electronic leak detector, leaving it in the on position while we're performing our service. If we get a leak, this should start to alarm and allow the technician to know that something has happened to change the environment and that it potentially could be flammable. As we continue with the leak detection and line repair, at some point we're going to have to remove the gas from the appliance. In order to do this, it's much easier to directly discharge the gas straight into the environment by using our discharge hose and routing it through a window or door. If this isn't an option, then using a temporary container such as a recovery bag or maybe even a recovery cylinder would be more appropriate. Keep in mind that if you use the bag or the cylinder for temporary storage, you want to discharge this immediately in a fresh air environment that is free from any ignition sources. Another component we want to stay away from is compressed air. Just like with our traditional refrigeration systems, we're not going to use any compressed air or oxygen for flushing the lines or blowing away debris or cleaning. Keep in mind that pure oxygen is an oxygenator and can be flammable in the right circumstances, and especially in introduction of petroleum-based products. Always use dry nitrogen if you need to flush your system. There are red marks that are going to be located near the process tubes on the appliance. These need to be maintained on the system. Some manufacturers use heat shrink sleeves, others will use actual paint to indicate that this is a flammable refrigerant inside of this system. So it's just an additional warning or visual indicator for the technician that there is indeed flammable refrigerants in the system. Always remove your piercing valves. This hasn't changed. Even with HFCs and traditional systems, you're always supposed to remove your piercing valve after service. There's always going to be a potential for leaks and should be removed and filled or the tube repaired after this service is completed. During the refrigerant removal phase of our service, we're going to want to ensure that we maintain ventilation. Again, having that floor fan or an intrinsically safe fan nearby to bring fresh air in will greatly prevent us from ever achieving that lower explosive or lower flammable limit we talked about previously. We want to maintain our proper grounds once again, and of course verify that we are using a refrigerant that is legal to discharge into the environment. If you're using R32 or R452B, you're going to need to actually recover these since they are HFC refrigerants. If you use a temporary vessel such as a recovery bag or a recovery cylinder, you do need to ensure that you empty this before you transport it anywhere. There's no point in putting a full recovery bag or full recovery cylinder filled with a hydrocarbon refrigerant that is no longer useful. Just simply discharge that into the air in an area that is risk-free and free of any ignition sources that could potentially ignite the gas. And of course, if you're using your equipment, hoses are going to be a big part of this. We're going to have quite a system of hoses. You want to ensure that they are all compatible with the refrigerant that you're using and are adequately long enough to either discharge outside of the home or to reach whatever recovery device that you're using. In recharging and replacing refrigerant inside of an appliance, the first thing we're going to want to do is match the refrigerant type. Again, as mentioned previously, this will be found on the manufacturer's label plate. In this case, we're doing R600A, and it has a charge quantity of 1.2 ounces. So obviously a very small charge. You'll see that there are significantly smaller charge volumes when dealing with R600 than you previously are used to with traditional HFC refrigerators such as a 134A refrigerator. We want to ensure that all of our electrical faults or problems have been repaired and placed back into operable condition before actually accessing the sealed system. Remember, anything electrical could be an ignition source, so let's repair that from the beginning, and then we can move to our sealed system repairs. Keep all our grounds in place, and make sure that as we're cleaning up or if you're accessing lines that you don't use any corrosive cleaning chemicals such as ammonia or bleach that may impact the actual service life of the copper tubing. It can degrade that over time. So try to avoid those cleaning products. And finally, we want to ensure that we renew and tighten any seals in our system. For most residential systems, the only real seals we can access are going to be the Schrader cores that are in the process tubes. It is appropriate to torque those down. You can buy a small torque wrench that will actually torque the cores to the recommended specification. And finally, once we've completed all our service, repairs, and inspection of the appliance, we want to make sure that all of the safety labels are still intact, and of course also the red markings on the process tube. You can again use heat shrink to place over the tube to indicate this, or use epoxy paint. The installed ventilation features, you must remain intact. You know, a lot of technicians don't understand that piece of cardboard is the true ventilation system on the back of that refrigerator. That helps to direct airflow across the condenser and across the condensate pan. This is also one of the locations where R600 could pull inside that condensate pan. If you had an inside the cabinet leak, it could literally come down the condensation drain and collect inside the condensate tray and remain there for some quite amount of time. R600 is a very heavy gas, and therefore can be still in whether a deck drain or a condensate pan. Any of those locations could house some refrigerant that leaked either from the service that you performed or a leak that was in the appliance previously. Another thing to note is when you are getting ready to open a sealed system is that just because you've recovered all the refrigerant doesn't mean that there's still not refrigerant in the system. Up to 50% of the refrigerant charge can remain emulsified in the refrigerant oil in a system that's been inactive for a long period of time. Couple that with lower ambient temperatures and you can see even more of a charge remaining in the oil. So keep that in mind during your service process. So we're getting ready to unbox our American VULKAN charging kit, also known as our US charging facility. We're going to go over all of the components contained in this kit that are going to help technicians safely perform a charge and recovery of any flammable refrigerant that you may encounter on a residential refrigerator. So the first component we're going to talk about is the actual discharge hose that comes with the kit. It's actually strapped right to the lid of the kit, And this is for the removal of refrigerant when you can discharge outside of the home. You could either route the weighted end of the hose outside of a window or through a door. Just be sure to always verify that the area where you'll be discharging the refrigerant is free from any ignition sources or high traffic. Next component we're going to take a look at is our electronic scale. Our scale has resolution available in grams or ounces so that you can easily convert in the field to whatever resolution or scale is used on the manufacturer data plate. Next component that we're going to discuss is the 4 accessory hoses that come in the kit. And those are utilized to join both individual single valve manifolds into one manifold assembly, simulating a 4-valve manifold assembly. Next component we're going to talk about is our low side manifold gauge. This gauge has a much higher resolution on the vacuum portion than your standard R134A gauge. The maximum pressure on this gauge is 45 psi, so be very careful. If you hook this to a 134A system, there's a high likelihood of creating an overpressurization and permanently damaging the gauge. Next component we're going to take a look at is going to be the high side manifold gauge. This gauge has a maximum pressure of 140 psi. So if you hook this to a 134A system that is in operation, you have a high risk of overpressurizing the gauge and permanently damaging it. Also, for mounting to the manifold sets, we do have 2 mounting hooks that will easily thread to the back of the manifolds, and that will allow you to conveniently hang the manifold sets from the appliance that you're servicing. The next component we're going to take a look at are our Schrader core depressors. It's a very handy tool that can conveniently turn any process port into an open and closed valve. Also included in this kit are 2 ball valves. One ball valve has a 1/4 inch SAE male and a 1/4 inch SAE female connection port. The other ball valve has 2 male 1/4 inch SAE ports for easy connection to your standard refrigeration hoses. The next component we're going to discuss is our bottle adapter. This is used to adapt our R600 refrigerant cans to a 1/4 inch SAE flare so that we can hook our refrigerant hoses to it. Please keep in mind that the adapter is made from aluminum and the can has steel threads, so be very careful when you're threading the adapter onto the bottle. We also have 2 T's included in the kit. One is for the adapting to our liquid charging stand, while the other is utilized to create a small manifold, which will allow us to both evacuate the system at the refrigerant bottle and the appliance itself. We also have 2 more longer hoses that are installed in the kit. They'll be attached to a check valve. This check valve is designed so that during the charging process, refrigerant can't flow backwards and back into the can. Please also note the directional arrow that's on the check valve. This is very important that the arrow should be pointing away from the refrigerant bottle or away from the source of the refrigerant that you're trying to charge into the appliance. So we've completed our review of the AHAM recommended procedures for handling R600 and other flammable refrigerants. So the first thing we're going to get into with our hands-in process is actually start our preliminary check. So we have our locator, which is a TLD 500, which is produced by Vulkan. This is our refrigerant leak detector, which also does detect hydrocarbons. So this is an all-in-one. It will go through a warm-up process that will take a brief 30 seconds or so, and then you'll hear indicated by a tone that it's actually functioning. Preferably, you'd like to take your electronic leak detector out to a fresh air environment to calibrate it. Obviously, here in studio, we haven't had a sealed system open yet, so we do know that it is a fresh air environment, so we'll allow it to calibrate here. So as we get our pulse, the TLD 500 will announce a constant chime as it's powered on. So this becomes our indicator that our environment is free of any hydrocarbons and we're not at risk of reaching our lower explosive or lower flammable limit. So I'll internal to the cabinet, so back by the vents where our evaporator would be located. Just make sure you don't get any continuous tones from the leak detector. With a lot of airflow, because the unit's running, you may get a couple fluctuations, but as long as we don't get a continuous tone, it should be free of any leaks. Focusing around the evaporator, come down to the condensing unit. Keep in mind with R600 it is a heavy gas, so predominantly it'll be found near the bottom of any of your components. I'm not getting any indicators on my leak detection system, so I'm going to let it continue to remain powered on. For video purposes, I'm going to go ahead and silence our locator just to not have the beep. I would highly recommend when you're performing your real service that you leave the beep audible, so it's not something you have to look at periodically. But to silence it, I just push the silence button here. And I'm just simply going to place it down on the table and allow it to monitor, placing the sensing probe near our work area so it can monitor for any discharge of R600A gas.